Hi all. Today we'll see about Introduction to Trigonometry, chapter 8.1. Okay, so we are given with 11 sums in trigonometry in exercise 8.1. We'll solve it one by one. We'll go to the first one and we'll solve it now. What is given is in a right angled triangle ABC. Usually if they give it as like a triangle A, B, C and C, this means it is right angled at B. Okay, so we'll take this is B and AB is going to be 24 centimeters is given and BC is going to be 7 centimeters and AC we do not know, we have to find it out and we have to determine sin A, cos A and sin C, cos B. So we all know about the Pythagoras theorem. So by Pythagoras theorem, AC square, that is the hypotenuse square, is equal to this side, one side AB square plus another side BC square. Okay, so AC square is equal to this square goes to the opposite side as root AB square plus BC square. On substituting, AB is nothing but 24 square plus 7 square. So this is nothing but root of 24 into 24, nothing but 576 and 7 into 7 is 49. So it is root 625, nothing but 25 centimeters. So AC we get it as 25 centimeters, that is the hypotenuse. Hypotenuse will always be greater than these two sides in any right angled triangle. Okay, so by this we'll find sin A and cos A. First one, sin A and cos A. This is angle A. So what will be sin A? Opposite divided by the hypotenuse, right? Opposite is BC, opposite by hypotenuse, and cos is going to be adjacent divided by hypotenuse, right? So opposite is nothing but BC divided by AC, and adjacent is going to be AB divided by AC. So this is BC is opposite to angle A and AB is adjacent to angle A. It is adjacent to this angle and this is opposite to this angle. It does not touch the angle in any way. That is nothing but the opposite side. So BC is nothing but 7 by, we have got it as 25 and AB by AC is nothing but 24 divided by 25. That's it. We have solved the first one. Going back to the second one, it is sin C and cos C. Okay, where is C? This angle. Simply, we can easily say opposite of angle A is BC, which is going to be adjacent to angle C. Am I right? Opposite of angle C is AB, which is adjacent to angle A. So, we can say sin of A is equal to, what is sin A? Opposite by hypotenuse, BC by AC will be equal to cos of C. Cos of C is adjacent by hypotenuse. Am I right? So, sin A is equal to cos C. Parallelly, cos A is equal to sin C. We'll try to solve that. Sin C is going to be AB divided by AC and cos of C is going to be BC divided by AC. What is AB? It is 24 divided by 25 and this is 7 divided by 25. Is it correct? 7 by 25. Sin A is equal to cos C and cos A is equal to sin C. We have got that. Going back to the second one. Going to the second question. They have asked tan P minus cot R. Okay, so in any triangle, they have given a triangle PQR, which is right angled at Q and PQ is going to be 12 centimeters and this is going to be 13 centimeters. So according to Pythagoras theorem, if two sides are there, we can find out the other side, right? So two sides are given. So according to Pythagoras theorem, hypotenuse square is equal to both the sides, square of both the sides. So PR square is nothing but 13 square, that is equal to 12 square plus QR square, which we do not know. This is 169, this is 144 plus QR square. So QR is equal to 169 minus 144 will be, what will be the answer? 25. Am I right? 25 square, which is nothing but QR is equal to 5 centimeters. Whenever you find an answer, it is good that you place a box so that it will be highlighted. It can help your presentation better. So we have found all these things. We are going to find tan P and cot R. What is tan P? It is going to be, we can say, 3 formulas for that. For tan, we can say it as sin P by cos P, which is nothing but opposite by adjacent. It can also be said as 1 by cot P. Parallelly, cot R can be said as cos R divided by sin R, which is also equal to adjacent divided by opposite, which is the same reciprocal of tan, right? So it is 1 by tan R. Now we'll try to find it out. Tan P, which is this angle. P is this angle and opposite is 5 and adjacent is going to be 12. So it is 5 by 12. Hope you all understand. And cot R is going to be adjacent by opposite. So this is this angle, adjacent by opposite, which is again going to be 5 by 12. So now what will be tan P minus cot R? Both are the same and it is going to be 0 from 1 and 2. Got it? We'll go to the third one. Sin A is given as 3 by 4 and we are asked to calculate cos A and tan A. Okay, so now let's assume this is going to be 3k and 4k. For a constant k which is going to be any kind of a positive integer, we can assume it. Okay, so we'll assume A, B, C, a triangle which is right angled at B, and sine of this is going to be what? Opposite by hypotenuse. Am I right? So it's 3k, this is, we'll assume it is 4k, and this we don't know, we have to find it out by Pythagoras theorem. By Pythagoras theorem, AC square is equal to AB square plus BC square. So 4k the whole square is equal to AB square we do not know and we have to find it out. This is going to be 3k the whole square, which is 16k square AB square plus 9k square. Here we keep it as square because we do not know what the integer is. So we cannot cancel this 2 and we are keeping it this square as it is, and we are only solving this number. So 16k square minus 9k square, we can take it as 7k square, which is equal to AB square. So AB will be equal to root 7 and k. Okay, we have got it as root 7 and k, and we cannot solve it more than this. We have to find cos A and tan A. Cos A and tan A. What is cos A? What is the formula for cos A? It is adjacent by hypotenuse, and tan is going to be opposite by adjacent. So adjacent by hypotenuse is nothing but root 7k divided by 4k, and this is going to be opposite divided by adjacent, nothing but 3k divided by root 7k. Now here we can cancel k and k. So this is root 7 divided by 4, and this is 3 by root 7. Okay, that's it. Then we'll go to the fourth one. What is given is 15 cot A equals 8. So cot A is 8 by 15. So we'll again assume a triangle ABC where it is right angled at B, and it is given cot. What is cot? It is nothing but adjacent by opposite. Correct? Tan is opposite by adjacent. Cot is the reverse of tan. So it is adjacent by opposite. So adjacent is this and opposite is this. So this will assume it as 8k, and will assume it as 15k, where k is any constant integer. Now you need not keep it as k, you can keep it as x, a, b, whatever as you wish. For any integer it is going to be 8, and for this any integer it is going to be 15. And AC, that is the hypotenuse, we have to find it out by Pythagoras theorem again, because we have only the two values and one value is missing. So if we have all these three values, whatever the question is, whatever it is asked, either it is tan or it is cos or what angle, whatever angle they have asked, you will be easy to solve. For that you need all these three sides and you should know the angles. So now by Pythagoras theorem, AC square will be equal to AB square plus BC square. So AC is equal to root of 8k the whole square plus 15k the whole square, which is equal to, this is going to be 8 into 8, which is 64k square. Again, we do not know this integer k, and we are so keeping it as k square only. 15 into 15 will be 225k square. So it is going to be 289k square AC. So when we take it out from root, when it comes out of root, and this is going to be k. Square and root you can cancel, you know that. So this is 17k is this value, 17k. Now what they have asked in the question is, you can take your textbooks and see. It is given as sine A and secant A. Find sine A and secant A. Okay, so sine A is nothing but opposite by hypotenuse, which is 15k divided by 17k. K and k you can cancel here, and it is going to be 15 by 17. We can say it as 1 by cos, or we can say it as hypotenuse divided by adjacent. Correct? 1 the whole divided by adjacent by hypotenuse, and when it comes to the numerator, it is hypotenuse divided by the adjacent. So what hypotenuse we have found? It is 15k, and what is the adjacent for A? It is going to be 8k. So 15k divided by 8k, k and k can cancel, and it is going to be 15 divided by 8, secant A. So we have derived the answer. We'll go to the next one, fifth question. What is given is secant theta is going to be 13 by 12. What is secant theta? Secant theta is nothing but 1 by cos. So this is hypotenuse divided by adjacent. So by seeing the question itself, we should know either it is hypotenuse or is it adjacent or it is opposite. We are asked to calculate all the other trigonometric ratios. We'll assume a right angled triangle P, Q and R, where it is right angled at Q, and it is given hypotenuse divided by adjacent. This is going to be the hypotenuse. We'll assume it as 13K, and adjacent of let's assume this angle, and it's going to be 12K. So what is this angle? Again, we know by Pythagoras theorem, 13K square is equal to 12K the whole square plus QR square. So 169K square, 144K square plus QR square. When we subtract these two, we'll get 25K square root QR. Root and square you can cancel. So QR is going to be, when 25 comes out of root, it is going to be 5. 5 into 5 is 25. So 5K. We got this is 5K. And now when we go to sine of P, they have us all for theta. Let's assume it is P. So sine P is equal to opposite by hypotenuse, nothing but 5K by 13K, which is equal to 5 by 13. Cos B is nothing but adjacent, 12K divided by 13K, which is 12 by 13. And tan, we know that it is sine by cos. So 5 by 13, the whole divided by 12 by 13. When this comes to the numerator, 5 by 13 into 13 by 12, which is going to be opposite by adjacent, nothing but 5 by 12. 5K by 12K, nothing but 5 by 12. And secant is going to be 1 by cos, which will be the reverse, 13 by 12, which is already given, yet we write it again. Cosecant is going to be reverse of sine, 13 by 5. Cot of P is going to be reverse of tan, 12 by 5. So we have derived all the trigonometric ratios that are needed, and we'll next go to the sixth sum. They've asked for any two triangles. Let's assume this is A and this is B. Let this be C and D, and let this be E and F, right angle at E and right angle at C. For these two acute angles, and we know that in a right angle triangle, other two angles will be acute angles. Okay. And what is given is cos of A is equal to cos of B. Cos A equals cos B. This is given. What is cos A? AC by AD is equal to BE by BF. Let this be first equation. And now we have to see whether this angle is equal to this angle. Cos is equal to cos. Whether this angle is equal to this angle, we have to find it out. And let's assume CD by EF, which equals, what is CD? AD square minus AC square. I am saying this according to the Pythagoras theorem. EF is going to be BF square minus BE square. Alright. and this will be for any constant k as said for all the sums. We'll assume this k on here also, we'll assume it as k. As given in your example sums, you can take it as k. So, when we substitute, if CD will be equal to EF, we have to substitute any one value, either CD in EF or EF in CD. We'll substitute EF in CD. That is, if we take it out for any constant k, BF square minus BE square the whole divided by BF square minus BE square. So cancel, we'll get it as k. Let's assume this is 1. And if the angles are going to be equal, the sides are going to be equal, let's assume this is also k. This is first and this is second. So from 1 and 2 we can say that this angle by this angle, that is adjacent by adjacent, hypotenuse by hypotenuse, opposite by opposite, all are related together. So we can arrive it as AC divided by BE is equal to CD divided by EF, which is equal to AD divided by BF. Moving to the 7th sum, what is given is cot theta is going to be 7 by 8, and now we have to evaluate 1 plus sin theta into 1 minus sin theta and 1 by cos theta into 1 minus cos theta. If cos theta is going to be 7 by 8, it is nothing but adjacent by opposite. So adjacent by opposite, we have it as 7 by 8. We'll assume it is for any integer k. So in a triangle, theta, r and s, let's assume it is rectangled at r. Okay, so adjacent by opposite for this theta is going to be QR divided by QS. So QR is 17k and QS is 8k. So this we can find it out by Pythagoras theorem. 8k square, 8 square k square is equal to 7k the whole square, or we can say 7 square k square plus rs square. So rs we can and when k comes out of square and root will get cancelled, so root 15 k root 15 or root 15 k. This is rs. And now 1 plus sin theta into 1 minus sin theta, 1 plus cos theta into 1 minus cos theta. which will be equal to, what is sine opposite by hypotenuse for this theta? So 1 plus, what is opposite by sine? We all know a formula, a plus b into a minus b. A plus b into a minus b will be a square minus b square. In the same pattern, here we can use it as a square minus b square, and here we can use it as a square minus b square. Right? So 7k by 8k, and this is if we take it as a plus b, a minus b, a plus b, a minus b. So 1 square minus k root 15 by 8k the whole square divided by 1 square minus which will be 1 minus k will be k square, and 15 will be root 15 will be 15, and this will be 64 k square. Am I right? 1 minus 49 k square divided by 64 k square. 64 minus 49 divided by 64. 64 minus 15 divided by 64. Minus, we are taking LCM, nothing but. So 1 into 64k square will be 64k square minus 15k square divided by 64k square whole divided by 64k square minus 49k square divided by 64k square. This and this can be cancelled, right? Because when this goes to the numerator, this will be reversed. This will be in the numerator and this will be in the denominator. So this minus this is 49k square divided by 15k square. This we can cancel, and the answer derived is 49 by 50. This is the answer for the first one. Going to the next one, cot square theta. And cot is nothing but, we know it is 7 by 8, which is already given in the question. Have to find it out, and given is cot theta equals 7 by 8. So what will be cot square theta? Square, that will be the cot square theta. So 49 by 64. So in this triangle, cot of A will be opposite by adjacent or adjacent by opposite. I hope you all will guess. Cot is nothing but adjacent by opposite, that is 1 by tan. Okay, so adjacent by opposite. If we assume it as something k, it's going, this we can assume it as 4 and this we can take it as 3. Am I right? So now what will be tan? Tan will be opposite 3 by 4. Simple. So 1 minus tan square A will be 1 minus 4 by 3 the whole square divided by 1 plus 4 by 3 the whole square. This is LHS. We are proving for left hand side. So 1 minus 16 by 9 the whole divided by 1 plus 16 by 9. So which will be 9 will come here. So this is minus 7 by 9. Am I correct? Equals minus 7 divided by 9, the whole divided by 9 plus 16 will be 25. 25 divided by 9. And when this comes to the numerator, minus 7 divided by 9 into 9 divided by 25. So which is minus 7 divided by 25. This is what we have got as LHS. Now we'll solve it for RHS. If we solve it for RHS, right hand side, what they have asked is cos square A minus sin square A. So we do not know the hypotenuse now. First we have to find the hypotenuse for finding all the other angles. So by Pythagoras theorem, what we have, 4 and 3, we have two values. So 4 square plus 3 square is equal to the hypotenuse for some k, for some integer k. So this is 16 plus 9 is nothing but the hypotenuse, that is 25. Okay, so hypotenuse is going to be 25. If we find cos and sine of these angles for A, in that right angled triangle, again I am drawing here, A, B, C, right angled at this is going to be 4 and this is going to be 3, and this we got it as 25. Root of 25, which is nothing but 5. And now with this we'll try to find cos and sine. What will be cos of A? It will be adjacent divided by the hypotenuse, so it is going to be 4 by 5. And sine of A is going to be opposite by hypotenuse, which is going to be 3 by 5. Now we'll solve for RHS, that is cos square A minus sine square A, nothing but 4 by 5 the whole square minus 3 by 5 the whole square, which is going to be 16 by 25 minus 9 by 25. So this is minus 7 by 25. This is the RHS. So what we got as LHS, minus 7 by 25. RHS also we got it as minus 7 by 25. So hence proved LHS is equal to RHS. Now we'll go to the next one. We'll go to the 9th sum. What they have said is, in triangle ABC, right angled at B, okay, if tan is going to be, tan A given is, tan A is going to be 1 by root 3, find the value of sin A cos A plus cos A sin C, and the second one. So if this is going to be the tan, this is nothing but tan of A. This is nothing but opposite by adjacent. So opposite is going to be 1 and adjacent is going to be root 3. So now itself we'll find what is the hypotenuse by Pythagoras theorem. By Pythagoras theorem we have 1 square plus root 3 square is equal to the hypotenuse square. So 1 plus 3, square and root will get cancelled, so we'll get 1 plus 3 is equal to AC square, which will be root 4. That will be 2. So AC is equal to 2. We have derived this value. This is going to be 2. Now we'll solve for sin A cos C plus cos A sin C. This is the first one given. So sine will be, sine of angle A will be opposite by hypotenuse. So 1 by 2 into, this means sin A cos A means it is understood that it is multiplication. Here also it is understood that it is multiplication. Okay, for any other value, either it is addition, subtraction or division, it will be mentioned in the sum. For multiplication, we have to understand it will not be given. It is understood here. And cos of C, what is cos of C? It is going to be adjacent by hypotenuse. So again it is going to be 1 by 2 plus cos of A and sine of C. Again both are the same values. Cos of A will be adjacent by hypotenuse and sine of C will be opposite by hypotenuse. Both have the same value, root 3 by 2. So it is root 3 by 2 into root 3 by 2. So we have 1 by 4 plus root 3 into root 3 will be, root and root will get cancelled. So it will be 3. That is, I'll clearly explain. Root 3 square. So square and root will get cancelled, divided by 4. 4 by 4, which is equal to 1. This is the first one we have derived. And the second one is going to be cos A cos C minus sin A sin C. Second one, cos A cos C minus sin A sin C. We'll draw again the same triangle here for reference. A, B, C, root 3, 1 and 2. These are the values we have got. Root 3, 1 and 2. So now what will be cos A? It is going to be adjacent by hypotenuse. And what will be cos C? It will be again adjacent by hypotenuse. So root 3 by 2 into 1 by 2. By 2 into 1 by 2 minus sine of A will be opposite by hypotenuse, so it will be 1 by 2 into sine of C will be opposite by hypotenuse, root 3 by 2. Simply we can say the value is going to be 0 because both are the same values even if you multiply. Root 3 by 4 minus root 3 by 4, which is nothing but 0. The sum, what we have given is, there is a right angle triangle PQ and R, right angle at Q. PQ is given as 5 centimeters. PR plus QR both, let's assume as X and Y. So X plus Y is given as 25 centimeters and PQ we have it as 5 centimeters. This is given. You have to write given. Then by Pythagoras theorem, so from Pythagoras theorem what we derive is that x square is equal to 5 square plus y square. Instead of y we can take it as 25 minus x square, right? From this equation, from equation 1. So from 1, x square is equal to 25 plus y can be taken as 25 minus x square. So x square is equal to 25 plus 25 into 25 will be 625 minus 50x, 2 into 25 into x. Solving an equation, a minus b, the whole square will be a square minus 2ab plus b square. So now solving for x, if this comes minus 50x will come as plus 50x to the left hand side, which equals, this both will get cancelled. 625 plus 25 will be 650. So x is going to be 13 centimeters. Is 13. Now according to the Pythagoras theorem, according to Pythagoras theorem, 13 square is equal to 5 square plus y square. We can arrive it by two options. We can either use Pythagoras theorem or we can apply this x value in equation 1. Both are correct. So 169 is equal to 25 plus y square. So y square will be 144, that is y is equal to 12. This is one way of arriving, and the next way will be x in equation 1, that is 13 plus y is equal to 25, so y will be 12. We can arrive either by this way or by this way, both are correct. Now we'll go to the now by determining the values of sin p, cos p and tan p, what will be sine of p? This is angle p, and what will be sine p? It will be opposite by hypotenuse. So it is, what is y? We have derived it as 12. 12 by 13. Now, what will be cos p and tan p? Cos p will be adjacent by hypotenuse, so it is going to be 5 divided by 13. And now what is going to be tan p? It will be opposite divided by adjacent. So it is 12 by 5. That's all we have derived. Moving on to the 11th sum. What is given is the value of tan A is always less than 1. Justify your answer. So we'll take a right angled triangle. Right angled at this. Let's assume this to be 2 and let's assume this to be 3. If this is 2 and 3, 3 square plus 2 square. 9 plus 4. That will be the value of this. Correct? 9 plus 4 will be root 13. So this will be root 13. Now we'll assume tan of this value will be 3 by 2. 3 by 2. Tan of this, which will be 1 point. We can assume it around 1.5 or something. So if we take the tan of this angle, it can be 2 by 3. 2 by 3, which is 0.66 blah blah blah. So both the possibilities are there. It can either be greater than 1 or it can either be less than 1. So the first one, what is given is false, because value of tan is always less than 1 is given. It is false. It can be both values. Moving on to the second one, secant A is given as 12 by 5 for some angle of A. Let's what is given is, we'll assume a triangle. Secant of A, right angle at this value. Secant will be what? Hypotenuse by adjacent. Hypotenuse by adjacent is given as 12 by 5 for any angle of A. What they have given, we'll assume any angle of A. If we try to solve this by Pythagoras theorem, 12 square equals 5 square plus BC square. So 144 minus 25 is equal to BC square. BC square will be 119. So BC will be root of 119. So it is possible that for any value of A, these two values can be this. Moving on to the third one, cos A is the abbreviation used for the cosecant of angle A. Is it true? Abbreviation for cos is nothing but cosine. It is not cosecant. Cosecant is what? 1 by sine is nothing but cosecant. So this is false. We're moving on to the fourth one. Cot A is the product of cot and A. False. Cot A is actually not the product of cot and A. It is rather, it is the angle. It is an expression of any angle in a right angled triangle. So it is not the multiplication, or it is not the product. Next one is sin theta equals 4 by 3 for some angle of theta. Is it possible to be 4 by 3 for sine? Let's assume A, B and C, and we'll assume it as sine A, which is opposite by hypotenuse. This is 4 and this is going to be 3. So 4 square plus some x square has to be 3 square, which is 16, plus x square has to be, x square is 9 minus 16 if we cancel this root. So it is a minus value. It is true. So with this we are completing exercise 8.1. If anybody has any doubts or queries, do comment, do post in the comment box. If you like the video or if you understand the video what I have posted, please do like and please do subscribe for the next upcoming videos. Thank you.